The physics of pole vaulting. Pole vaulting requires speed, strength, and mass to achieve a better pole vault. Here is an example of a pole vault, but not just any pole vault. The men's world record set by Renaud Lavillenie of France, who jumped a staggering 6.16 meters high. Notice how fast he runs, how much the pole bends, where the time of jump, and how he swings his body, the recoil of the pole. All these factors come into play for an amazing pole vault. Variables that come into play are the velocity of the vaulter, their mass, and the height of which they can potentially jump. When analyzing conservation of energy, we can see that the kinetic energy of the approach, the elastic potential energy, the kinetic energy of the vault, and the gravitational potential energy are all equal. So, kinetic energy of the approach is equal to the gravitational potential energy at the top of the vault. 1/2 mass times velocity squared is equal to mass times gravity times height. We can now see that initial velocity is very important for the obtainable height in a pole vault. The greater the speed, the greater the height, because kinetic energy is generated from gaining velocity. But how does kinetic energy of the approach become a vertical kinetic energy? The elastic potential energy of the pole. The work done by the kinetic energy of the approach is applied to the pole, converting into elastic potential energy, which bends the pole. The vertical kinetic energy of the launch is from the recoil in the pole, transferring the elastic potential energy into the vaulter as kinetic energy once again. The efficiency of the sport's performance will not equal 100%. This is because some of the energy will be lost due to poor form in the vaulter, reverberation in the pole, and also in heat and sound energy. Many things have been done to improve upon the achievable height of this sport. The main focus has been the pole itself, which has evolved tremendously. In the mid-19th century, the poles used were heavy, rigid hardwood such as ash or hickory. Throughout the vault, the pole remained rigid and had essentially no bend. They could not transfer horizontal motion into upward motion efficiently, as a large amount of energy was lost in the plant and vaulters were constrained to lower heights. Bamboo poles replaced the hardwood ones. Since bamboo is naturally hollow, they were much lighter and could bend slightly when stressed. The hollowness also made them easier to carry, and the athlete could run faster. Vaulters were also able to carry more energy into the vault and convert more energy into an upward motion. The next major advancement in pole technology was the use of carbon fiber and fiberglass materials. Different layers to the pole are what allowed the fiberglass to be so versatile and effective. With minor adjustments to the structure of the new poles and the addition of carbon fiber layers, these poles have become significantly more efficient at transferring and converting the vaulter's energy. These poles are substantially stronger, lighter, more flexible, and more responsive than any other pole used before, and have allowed pole vaulters to launch themselves to even greater heights.